Hi everyone, I am Raymond from Best Fruits in Jamaica. Today I will be discussing grafting as a method of propagating Naseberry. First, grafting is a method of asexual plant propagation that joins plant parts from two different plants in such a way that they become attached and grow as a single plant. This technique is used to propagate plants for the following reasons. 1. They might not root well from cuttings or by circumposing, which is also called air layering. 2. To utilize superior root system. 3. To maintain clonal production. And 4. To rapidly multiply single plants within a very short time. In simple terms, grafting is therefore the act of placing a portion of one plant, bud or scion, into or on a stem or branch of another in such a way that a union will be formed and the partners will continue to grow as one unit. The part of the combination that provides the future root system is called the stock, while the added piece, which later develops to form this single shoot system, is called the scion. Before the development of genetically modified organisms, grafting was the only way of ensuring that superior genetic characteristics shown by some plants were introduced from their countries of origin to other countries of the world. There are lots of ways to graft plants. However, the technique that I will be using in this video is a modified form of cleft graft. This is one of the simplest and most popular forms of grafting. Many plant propagators have modified cleft graft method to suit their needs. Since I began using this procedure, I have been getting over 95% success rate. I must say that I do not operate a commercial nursery. However, I have successfully grafted numerous plants using this method. I am confident that this procedure, if used by other plant propagators, they should be able to achieve close to 100% success rates. One of the most important tasks in preparing for a grafting session is the bud or scion selection. Normally, the shoot or apical meristem at the tip of the plant has three roles. 1. It is the source of new cells that are needed for stem growth. 2. It is the site of small cellular outgrowth called leaf primordia that develop into leaves. And 3. It is also the site where flowering and subsequent fruit set takes place. It is therefore important for us to select scions that will give us the desired outgrowth or shoot. A detailed examination of emerging shoots on a flowering Naseberry tree during one of their regular flowering seasons will reveal various meristems to be differentiated in the manner just described. This observation also reveals that the majority of younger shoots usually develop only leaves. However, the success rate when they are used as scions for grafting were not very favorable. The medium-aged shoots, which give the best results when used as scion material, were showing development of leaves and flowers, while older shoots were differentiating into stems, leaves, and flowers. Most of the time, however, they were often too old and too large for the regular stock size that are normally used in grafting. The ideal shoots to select as scion are therefore the medium-aged shoots, as they have shown best results. The scions that I normally use from the medium stage are those that have just changed to a complete light brown color and having emerging leaves being approximately 1 to 2 millimeters in length. Before collecting any scion for grafting, a brief examination of the stock suitability and size is usually done first, as the size of the stock is usually the criteria used to find a suitable scion. The best quality scion wood usually comes from shoots that are just emerging from dormancy or those with an active apical meristem. In layman's terms, it is often described as when the buds have just started to push. In addition, the health of the scion should be at its best before it should be considered for grafting purpose. Scions should be severed with a sharp, clean clipper or knife. at a length of approximately 4 to 6 inches or 10 to 15 centimeters, after which excess leaves are then removed, leaving approximately 7 to 9 leaves on each scion. These are further cut into halves with the use of a clipper or a pair of scissors, after which they are secured in either a moistened burlap, damp paper towel, or a plastic bag to prevent them from losing too much moisture. For a single graft, at least 2 scions should be collected. However, in order to ensure that the scion size is almost identical to that of the stock, some propagators will collect an additional 2 to 3 larger scions and 2 to 3 smaller scions than the estimated stock size. This is necessary if the scions are being collected from a far distance from where the actual grafting will take place, and is to compensate for any under or overestimation of the stock size that might have occurred on the part of the propagator. It is a good practice during the harvesting of scion and while conducting the graft to clean the cutting tools regularly. This may be done by spraying and wiping them with a sterilizing solution. Isopropyl alcohol, also known as rubbing alcohol, can be used. Stock preparation involves a more detailed examination of the stock in order to determine its approximate diameter at the point where the upper portion of the shoot will be removed. If the seedling has several branches, all should be removed except the most suitable branch for attaching the graft. Sometimes the most upright or vertical shoot is not the most suitable for grafting. The graft can be done anywhere below the point that coincides with that area where the most mature part of the youngest shoot from above meets the youngest part of the stalk from below, and usually extend further down the stalk until the woody stem becomes unfavorable to receive the graft. At the point where the graft will be done, the physiological state of the stalk must be such that it is capable of producing callus tissue necessary for healing the graft. The youngest portion of the stalk is removed, and also the upper leaves nearer to the top of the severed stalk. It is recommended that some leaves be retained on the lower portion of the stalk at grafting. These will provide most of the food that will be needed for the healing or callus development between the cut stalk and scion of the grafted plant. The stalk is then gently and carefully split open at the center to a depth of 1/4 to 3/4 of an inch or 6 mm to 2 cm to accommodate the scion. The scions are next taken from storage, and a suitable one that matches the size of the stalk is selected. Before doing the graft, it is always advisable to cut off about approximately 1/4 to 1/2 of an inch or 6 mm to 1.25 cm of the lower end of the scion, after which a visual check of the cut end is made to ensure that there are no discoloration within the plant tissue when the bottom of the scion is cut off, as any discoloration would be a clear indication that disease-causing agents have already established themselves within the cut end, and this could result in a complete failure of the graft. This is extremely important when using scions that have been stored for any appreciable time. In addition, whenever a plant is cut, the cut section normally creates an instant barrier which seals the conducting vessels of the plant to prevent intrusion by disease-causing organisms from the environment into the plant conducting tissues, and to prevent moisture loss from the plant through the cut end. The scion is then shaped and securely placed into the prepared stock with barks of both the stock and scion matching up at least on one side but preferably on both. Here the cambiums of both stock and scion will be in contact with each other and will hasten rapid healing or callus development. They are then tied with grafting tape. Next, a 4-inch or 10 cm wide plastic bag is placed over the attached scion, after which a piece of old grafting tape or string is used to tie the bottom of the bag, preferably enclosing all aspects of the grafted area. The bag should be tied tightly around the stalk. What this does is to create an environment within the bag where the humidity will eventually approach 100%. This effect is similar to those of a humidity chamber or mist house, where the humidity is almost near or at 100% saturation with water vapor. This condition keeps the half leaves alive inside the bag. Therefore, provided that the half leaves were saturated enough and had not significantly wilted at grafting, they will remain alive, still carrying out the process of photosynthesis, contributing towards the rapid healing or coalescing of the cut stalk and scion. We should remember that leaves have natural openings called stomata, which allows for the passage of gases and water from the plant and air. This water will be trapped in the bag and is responsible for developing the humidity inside it. This is important in that immediately at grafting, there are no continuous conducting vessels between the scion and the stalk. Therefore, the new plant that we are making will concentrate most of its resources in trying to heal the wound as quickly as possible, establishing conducting vessels so nutrients and water can pass up or down the plant as the need arises. The plant should then be stored in a shaded area. This could be a special shade house where air can freely move in and out, thus regulating the temperature inside the bag within a range that the half leaves can tolerate. If a shade house is used, the roof material has to be made of shade cloth that will keep 50 to 60% of the sunlight intensity out. Alternatively, the plants can be safely placed under a tree that will guarantee them similar levels of shade. If the sunlight intensity is too high, the temperature inside the bag might get too hot, after which the leaves could die and the scion could follow shortly. I have had examples where the temperature was too high, resulting in the half leaves dying, but occasionally the scion sometimes survives. During the first 4 weeks after grafting, we should make sure that the plant is given enough water to satisfy its daily usage. If the half leaves are still alive after 4 weeks, providing all the plant daily requirements are being met, then the graft will be successful. Plants grafted this way should be left for at least 6 to 10 weeks or until growth of the apical bud has started, after which the tightness of the tied bag to the stalk can be slightly slackened to allow free movement of air inside and out of the bag. The bag should not be taken off immediately after the first observation of leaves growing out from the apical bud. Always allow 1 to 3 days to pass after slackening the tie on the bag before removing it completely. This is to allow the developing shoot to slowly adjust to the normal atmospheric conditions. It is important that weekly observations are made of the grafted plant, as there have been occasional instances where shoot growth were observed after 5 weeks. The time that the shoot takes to grow out after grafting is directly related to the state of the bud dormancy at grafting, along with the existing climatic conditions within the location of the grafted plant. We will first look at a graft that was done 6 weeks ago. Because of the water vapor inside the bag, the contents of the bag are not clearly visible. The outline of the leaves and droplets of moisture on the bag can be seen. In addition, one of the half leaves has fallen off from the scion. By slowly removing the bag, we first see the half leaf falling out. Closer examination of the apical meristem is distinctly showing the development of the leaf primordia, which is developing into leaves. Within 1 to 2 weeks, the leaves will be fully formed and the bag can be permanently removed. After the plastic bags are removed, they should be examined and any untorn ones should be sterilized, air dried, and stored to be reused for similar purposes, while the older ones can be used in other forms of nursery operations. These are 2 plants which were grafted 6 months ago using the same procedures just described. For the first plant, the grafting tape is yet to be removed, so we will proceed to do so. We can see 5 remaining half leaves from those that were left on the scion at grafting. Also, the length from the apex of the plant to the point of grafting has increased to approximately twice the length of the scion at grafting. The area of attachment and the healing scars are clearly visible. For the second plant, we can also see 5 remaining half-leaves from those that were left on the scion. The length from the tallest point on the plant to the point of grafting is approximately 10.5 inches or 26.7 centimeters. In this case, the top of the scion has produced 2 shoots or branches. The healing scars or callus formations are quite distinct in this case. If you have found this video helpful, please remember to like, share, and leave a comment below. If you would like to see subsequent videos of this nature, please subscribe to the channel. That is all for this video, but I will leave you with this thought. Increases in atmospheric carbon dioxide level are responsible for about 2/3 of the total energy imbalance that is causing Earth's temperature to rise. The levels of atmospheric carbon dioxide was reported in January 2022 to be about 416.45 parts per million in comparison to 1960 levels, which stood at about 316.91 parts per million. Plants are most efficient in carbon dioxide removal from the atmosphere. If you are listening to this message, please help to save Mother Earth by making an immediate commitment to get a tree planted between now and the next 2 weeks. Until next time, thanks for the commitment and thanks for watching.